So we're going to pull the wheel off. We're going to remove the axle flange nuts and pop the axle out. We're going to have something underneath to catch the oil, because it's going to be full of oil in that hub. And so we've got our oil catch tray underneath. So we'll just start here and we'll pull these off. What I like to do when I take these off is I like to leave the nuts on the ends of the studs. That way when I hit it with the sledgehammer, I don't hit, if I hit the end of the stud, I just have to change the nut, not the entire stud, as you would if you left them right off. So they're on the end there. Now when I take my sledgehammer, if I accidentally hit a stud, I don't have to change the stud, just the nut. And we're just going to hit right on here and pop that axle out. And then any oil that's coming out of there will drain out. We've got it up on a bit of an angle here, so we're not going to see too much oil. Pull these off. And then we'll pull the axle out, and that'll reveal our axle nuts underneath. There's the axle there that drives the vehicle. Set it over here so it doesn't fall on somebody's toe. And now you can see in here we've got our lock nut for our wheel bearings, and we're going to pull that off. And this particular nut here, they vary a little bit, but this one has two detents here that when the socket goes on, and you have to use a socket to get this style off, and you should be anyway, it'll go across the flats and it'll push the detents in, and now we can go ahead and we can undo the nut on here. You'll have to keep the socket on the whole way, because if you don't, then those little locking tabs will lock in there. If they're not in, you can't get it off or you'll break them. All right, there's our nut. And then the bearings inside. And what we'll do now is we're going to pull this wheel off, and then you can have a look inside there. What we're going to do is we're going to slide the wheel dolly in, and that's going to support our wheel while we slide it off the spindle. The whole hub and wheel assembly will come. We'll put our safety chain around. This is particularly important if you're doing a front wheel or a single wheel. You want to put this chain on. Just keeps the wheel from tipping off the dolly. Now we'll just lift it up till we get a little pressure. And there, it's off. Part of your inspection is you want to check the minimum lining thickness. Minimum lining thickness is done by taking a depth gauge or any other type of device that you can measure the depth on. So the minimum lining thickness allowable is 1/32 above the rivet, or 0.8 millimeters above the rivet. And you want to measure that and record that on your safety standard inspection sheet. So you just basically put it over top of the rivet there and push down, and it'll tell you the depth remaining above the rivet. If it's a bonded lining, in other words it's glued here to the table, then what you would have to do is you'd have to measure from the top of the lining down to the table, and you're allowed 2/32 or 1.5 millimeters above for that style. We've got riveted linings, we've got lots of lining on there. We're going to check to make sure that the linings are tight against the table here, not rust jacked up out of the way, that the lining is solid all the way through and not cracked all the way through. A little bit of wear on a used lining is normal, just as long as it's not severe heat checking or cracking on there. Okay, so what we're doing is we're adjusting up the micrometer, and on here we have the size dimensions. So we set it to 16.5 inch, so 16 on this one, 16.5 on this one, and now in a perfect drum it will come right to 0 at 16.5. And any wear that you have will start to go this way. If it's this way on it, that means that there's more material than 16.5 inches. This way is less than 16.5 inches, or oversized, so it's been worn down. And the maximum that you're allowed to go on these drums is right here, 120 thousandths of an inch over, 0.120. So if it's more than that, the drum has to be replaced. And anywhere less than that, you know, it's going to be your call based on the rest of the drum condition. But as long as it's not over 120 thou, it can be put back into service, provided it doesn't have any other problems with it. When we load this up, it's really important. Any dial indicator that you have, if you let it spring off, this part is on a spring, if you let it come out too quick, it spins the dial around, hits a stop, and knocks it off and throws it out of calibration. So in this case, what we'd like to do is to load up that end gently first, and then we'll put our other end in. And now we just move our micrometer up and down here. And in that case, we've got about 25 thousandths of an inch over. You can check it in several spots if you want here. And see. So there we're about 30 thousandths of an inch over size. So plenty of room, because we don't have to worry till we get over to the 125. Now when you take these out, like any dial indicator, you want to slowly unload the needle on it, otherwise you damage it. So what we're going to do is we're just going to push up on the needle a little bit. We're going to pull the bottom out and slowly release this so it doesn't spin back and break the needle off. This is one type of brake drum gauge that you'll use. There are other different methods of measuring, but this is probably your most common method. And you really need to be measuring the drums on a safety inspection. So what I'm going to do is I'm just using a large adjustable. You could use a pry bar down in here. What we'll do is we'll pop the rollers out of here first. Watch you don't get your fingers slammed in there. Now once those are off, the rollers, we can clean and inspect them. Spend the time then, clean it, look at it, examine it. This is the time to order the parts if you need it, not when it's going back together. And what we're feeling for on here is we're feeling for flat spots. And in fact, this one does have some flat spotting, minor flat spotting on it that you can feel. I would change those over. They come with the new shoes. This roller here, we want to check the edges where it wears on the table, and we want to check the face for flat spotting. We do have a little bit of, you can just barely see a flat spot on there now developing. This means that we're going to wear out that. It's not going to roll when the cam turns on it, and that's what you want to do. That's why when you lubricate these, you only lubricate the edges here, never the face. If you lubricate the face, then the S-cam, as it moves on, it'll slide, and that gives you flat spot. Now we're going to take the rest of the brakes apart, and we'll inspect them on the way. Just grab onto here, and here. Let that up and off. There we go. And then just unhook that big front spring off the front. And then we'll carefully take the bottom shoe and just wind it back. And there's your primary shoe off. And then we just pop our secondary shoe off. And we can have a good look at the table here for damage on it, any cracks in the welds, and we can have a real good look at the shoe surface, which looks good, and we can have a quick look at the springs. There's no tensioning gauges to check the springs. They're just changed whenever you change the shoes. We can also check the anchor pins here. We want to make sure that these anchor pins are free and lubricated. Now these anchor pins you can lubricate across the face of them as well as the ends, because they want to move in these bushings here in the spider, right? So if they're not moving freely, you want to press those out and then put in new ones that come with your shoe kit. Here we have the wheel speed sensor, and we want to make sure that that wheel speed sensor moves all the way forward. So it's all the way out, and then it'll bump back in when we put the wheel on. Want to check your spindles nice and clean, and that there's no wear marks where the seal sits here. You shouldn't be able to catch any grooves with your fingernail on there. That should be good. And where the bearings run should be clean, and our threads should be nice clean on there as well. Then the S-cam, we want to make sure the S-cam isn't all flat spotted on the outside here as well. That one seems good. And we can put a dial indicator on there, and we're going to check the play of that. So all we do here is we just put on our dial indicator magnetic base here, and we'll bring it up to our S-cam head. So if you want to, you can zero the dial, otherwise read total indicated run out. And we're just going to move the S-cam up and down, and we're going to read the total indicated run out. So in this case we got 10, 20, 30, 40, 50, 60, 75. And back to the 10. So 75 minus 10 is 65. So we've got a little bit excess of clearance in there. So in that case, the best thing to do here is to take the S-cam apart and replace these bushings in here. You don't want it any more than 30 thousandths of an inch up and down, because that's used to take away some of the timing for the brakes. So we want to get that fixed. Now the other thing, and that's the bushings inside here that get changed. The in and out play, we can measure that too. So what we're going to do is we're going to check the in and out play of the S-cam, and we're going to put the dial indicator on, and we're going to move it all the way out here. So we're at 5, and then we're going to slowly move it back in. So we're at, oh, there's 1 revolution to the 8, and two full revolutions of this. So we've got 200 thou. The maximum allow is 60. That's controlled now. Back in on the end of the S-cam, we put shims in here to control the amount of in and out play. So what we would do now is we'll just go and we'll add some shims to the back and get this in and out play between about 5 and 60 thousandths of an inch in and out. You get too much out play, the cam tends to walk out. You can have the rollers wearing odd on here, or other problems that can occur. You want to keep that no more than 60 thou on the in and out. So we want that thing all the way forward here, which it is now. And then as we put the wheel on, let's put the shoes back together. Just going to use some anti-seize compound here, and we're going to lube up some of our brake components. If you have a high temp drum brake silicone lube, you can use that too. We want to put some lube on these things because it's going to help to keep them from seizing up right away with rust and so on. The manufacturer may have you put on their specific product. So we'll just slide those in. These are the anchor pins we're putting in now, so we lubricate those up. Okay, so once those are lubed up, they can go into the holes. We're lubing these anchor pins all the way around because they want to move in their bores, plus they want to move on the end here. We can even put a little lube in here on the shoe on both sides here. This just helps reduce coefficient of friction, make things turn easier, and helps to keep the rust out of there too, to get any moisture in there. And we're just going to lube on the rollers, S-cam roller end. We just lube these only. We don't lube the face of it as we talked about. Now, when we put it together, what we're going to do is we're going to start with our top shoe here. We're going to make sure that this little pin here has to be in place. If it's not, it comes with the kit, and you just get it lined up and use your hammer and tap it in, and it'll stay in there. And what we're going to do is we're going to put the top shoe on first here, and then we're going to take our springs for the bottom shoe here. And we got one on here already. And we just hook these right on here like so. And then we'll get our top spring hanging ready to go. And then with the rollers out, we'll just stick this on the back here. We'll hook these springs in the back. Then you can get the outside spring. And now what we're going to do is we're just going to roll that right up in place like so. Hold the bottom shoe, and now we should be able to get our big spring on here and here. Sometimes you have to use a tool to get them on. These are the rollers that are going to go in. Now on these rollers again, because of flat spotting on here, we never ever put any lube on here. And we certainly don't put any lube on here either, on the face where they come up to it. Because if you do, it causes them to slide and they flat spot. And that's not good for the braking system. But if you want to put a little lube on them, they recommend that you put it right on the outside here where it's going to fit right into the table. Well, and we had put a little lube in here as well. So put that lube on there. And now I'm going to get this one lubed, and then we'll slip them in. I like to put the top roller in first. Some of these rollers come with little retainers, some don't. This particular one didn't, and that's fine. So what I like to do is get my big adjustable wrench. You could use a pry bar in here, but it could slip, so I prefer personally to use the large adjustable wrench and just slide it up over the shoe here and tighten down a bit. Watch your fingers when you put it in that they don't get pinched there. And then what we'll do is we'll put the bottom roller in here and try and just get that in there like so. And now the wheel's ready to go back on. What we're going to do next is we're going to just pull that wheel bearing out. And there's a number of ways you can do it. The best way is to use a seal puller. What we're going to do is we're going to pull it right out of there. And watch that bearing doesn't hit the floor, because that can damage it. Now we got the seal out. That's garbage. The bearing, what we're going to do with the bearings is we're going to take them over. We'll clean them up, and we're going to have a quick look at them and inspect them. What we want to look for is we want to look for anything we can catch our fingernail on the bearing rollers themselves, any pitting in there that's going to affect the operation of it. And we also want to get into the light and look at the inner race as well and look for any pitting inside there. We can give it a small spin test. You don't want to spin a bearing with compressed air, because if there's dirt in there, it could damage it. But just give it a nice turn, and it should feel smooth all the way around. You shouldn't feel anything lumpy or bumpy, otherwise the bearing will be changed. When you change the bearing, there's a part number on the back. You also change the inner cone as well, and we'll inspect this inner cone here also to make sure that it's wearing properly. We want to make sure our tone wheel's good for our ABS brakes and not rusted or damaged, and that the bore that the seal fits in is clean. We'll get our new seal here. One of the things that you'll have to do is when you get a new seal, you're going to have to know the number of the seal. These are pretty standardized seals, so your parts department should stock them. But inside the seal here, we've got a number here, and then the number corresponds to the number on here. So we've got a CR 47697 seal. And we'll just look on the end of the package here, and it says right here, use tool 436. Now when you install these, you need to have a set of seal drivers from the company that makes the seal. We'll make sure we grab the right driver here. So we've got our seal out. It'll tell you oil side or bearing side. It's written on here, so you know which side the bearing goes to. So basically what you get here is you get the driving handle, you get the driver, you get the bearing cones, various different bearing cones, and they just all do up together on this shaft here. This is nice because now you hold the bearing cone centered in the race, so you can't damage the bearing case or the bearings going in, and you don't have to lay this great big 400-pound wheel down on its side to drive it in straight. You can leave it on its side, and this will hold everything nicely, and we just drive it right in. I wouldn't suggest putting anything on the outside of these because the paint does that. So they can go in dry like that. We've got the bearing lubricated here nicely. So we just fit that up into the hole here and that in to the hub. And then we're just gonna get that nice and straight in there, straight as we can. And don't worry too much about it if it starts to go on a bit of an angle. I find getting it started is probably the little bit trickier part here. Okay, so that's good. Now our seal's in. You can hear how it changed when you hit home. Now to check to make sure the seal's in good shape, what we're going to do is we're just going to turn the inside of it, the rubber. This is a unitized style seal. On a unitized seal, the outside fits tight in the hub here, so it won't let oil by, and it turns with the hub. The inside of this rubber, it fits right on the spindle here, over here, and when it fits on there, it fits on tight. And now what you do to check it is you rotate the inner rubber like so. If it rotates, the seal's good. The seal actually wears inside of the hub. Get a lip type seal like in Stemco, the lip actually is stationary with the hub, or moves with the hub I should say, on the stationary spindle. And this edge here, if it's turning on the spindle, will cause a groove right in your spindle. So Stemco, they came out with a wear guard that goes on first, and then this on the spindle, and then the sleeve goes in. These unitized seals are very popular, very common. All right, so now we've got the seal back in. We've checked the seal to make sure that everything's good. Now what we can go ahead and do is we can put a little bit of gear lube right into this hub here. You may find it easier to add it from this side and just add some gear oil in there until it just comes to the top of the bearing race. And now we're ready to put it back onto our wheel dolly and put our wheel in. We got the new seal on, we got the bearing in, got everything set up there. We're just gonna slide the wheel up here, and we want to be sure when we put that wheel on that we don't catch that new seal on the threads of the spindle. So as you put it on, you want to have a good look inside here. right in the end there. You see the spindle? You want to have this thing up so that it's even. It's going to slide right in there without catching that seal. You have to line them up a little bit here. And then we should be able to, once we see that spindle nicely in the middle there, we can slowly approach it. If we're a little high or low, we can kind of make our adjustment as we go here. Just look at the drum on the back here. Make sure it's going on. Yep. And we might just have to lower it a bit because we're a little bit high. So we'll just take out our handle and we'll just drop this down just a wee bit. There we go. And now we should be able to slide it in here. There we go, just like so. There we go, we're all the way in. New gasket here, axle flange gasket. We'll take that off for the moment. We'll always use a new gasket for your axle flange. Now we'll take our wheel bearing. We've inspected our wheel bearing already, and the wheel bearing looks good. There's no major pits in there, anything that's going to damage it. We can look at the end of the rollers here, make sure they're not worn. Have a look at the cage, make sure it's in good shape all the way around, not grabbing any of the rollers. And the inner race to make sure there's no pitting inside there. You can give it a slight spin test just to make sure it rolls nicely. And now put a little bit of lube on it and some gear oil. Just put a bit on there. And then that's all pre-lubricated, ready to go. And now we'll get our inner nut here and our bearing, and we just slide the bearing in like so. There we go. And now we can put our nut on. If we look at this particular axle nut, and these are quite popular, this ring here that fits onto the spindle groove, keyway groove, and then these little guys here, these indents get pushed out of the way, so that's your lock on it, so it won't back off. These get pushed in, and now you can rotate it with the socket on. So when you put this style on, you got to put it on with the socket all the time, okay? Some of the other nuts you can do without, you can just hand thread them on. They have different locking devices. Okay, so we're gonna start the nut on here. Okay, all right, now just snug that in. That way, when we drop this out of the way, wheel won't fall down. Okay, we'll pull the wheel dolly out. And now what we're going to do is we're going to do the TMC recommended wheel bearing adjustment procedure. We're going to torque this on. We want to go to 200 foot-pounds on the first. We'll set it secondly to 50 foot-pounds. So we'll wind it up to 200 foot-pounds. You should always unwind these torque wrenches when you're done to take the tension off them, or they lose their accuracy according to the manufacturer. If you're not sure the accuracy of your torque wrench, have your tool guy or take it to a tool company and have them recalibrate it. So we're right at 200 there. Zero's right on the mark. And now we can lock this ring here, and then it won't rotate. And now we're going to tighten that wheel bearing up while we're rotating it to 200 foot-pounds, and that seats the bearings. So we're going to tighten it down. I'm going to rotate a little bit here. That helps to seat the bearings. Rotate it a bit. Once we get it in a bit further here, it'll be easier to rotate. This seats the bearings and everything. We go 200 foot-pounds at first to make sure that everything's pressed in. Use this nut to press all the bearings right back. And then it'll give us a good seating on there. There we are. Now we'll back it off one full turn according to the Technology and Maintenance Council Repair Procedure 618. So we'll back it off one full turn. And we can rotate it a little just to let it find its home. And now what we're going to do, undo the lock, and we're going to bring it back down to 50 foot-pounds. And we're going to bring it up to 50 foot-pounds. The 50 on here and the 0 right on the center line here. And then we can lock it here. And with it locked, then we're ready to go. Now what we're going to do is we're going to tighten it up to 50 foot-pounds, and we're going to back it off the number of threads per inch on that spindle. We looked it up in the chart, and it works out to a quarter turn back. So we're going to tighten this thing up while we rotate it to 50 foot-pounds. And then we're going to back it off a quarter of a turn. So what you can do for that is you can get your torque wrench, say, level here. Now you know exactly where a quarter turn is up here. And that's it for this one. And then what we'll do is we'll put the dial indicator on and we'll check the end play. Always check your bearing end play after you do it, because otherwise you can't verify it's set up correctly. So if it's an aluminum hub like this one, I like to put the dial indicator right on the metallic spindle, and then we can come right up to onto a stud here, or the hub itself, and then we can check the end plate. So we're right on there, and now what we can do is we can check our end plate without rotating the wheel. What you don't want to do is you don't want to get the movement of rotating it. What you want to do is you want to get it pulled all the way one way. There's 50. And then we'll come back the other way without moving it. But we got about 0.02 of an inch end play. You're okay between 1 and 5. Okay, so this is our axle, and it's going to fit in to these axle flange fasteners. So we put on a new axle flange gasket here. You just buy those where you buy your seals. They're nice because they seal really well. They're easy to take off and put on. You put silicone on there, it doesn't stick. And also it makes a big, mess for the next guy to come and clean all this stuff off, right? See how that somebody had put silicone on there? That didn't even adhere to anything. I'd stay away from that and go with the purpose-made gasket. Now when you put these axles in, this axle here is going to spline down into your side gear. So when you put it in, it's going to be laying low like this in the hole. The side gear is right in the middle, so there's a little technique that's going to help you from damaging your fingers. So you'll feel it come in, and what you want to do is you want to grab the axle and you want to lever it up so the end goes into the hole in the side gear. And see how our fingers aren't in behind the flange here? Right there, when it went in, that would have caught my finger between the stud and the flange here, and that would have been a pinch point. That's not a good day at the office. So we want to avoid that. Again, see, my hands aren't in behind here, but they're on the outside of this, and we're just now simply allowing that to line up with the holes And once it goes pretty quick, so you don't want to have your fingers in behind there. You'll jam them up on something here, and that's not a nice day. And now what we're going to do is we're going to put the axle flange nuts on, and we're going to torque them to the specification that the manufacturer outlines. And then we're going to adjust up the brakes, and we're going to check the differential level, and make sure all the oil's off the inside of the hub and off the back of the wheel. If you've had a vehicle that's come in for a wheel cylinder, or pardon me, a wheel seal, there'll be oil traces on the back side of this wheel. It looks like it's still leaking. So you don't want to have the guy go out to the scales and then they say, well, there's oil on the back side of your wheel. It's a wheel seal leaking, and you know, it's only because you hadn't cleaned the oil off the back. It's a perfectly good wheel seal in there. So part of that job is to make sure the rim and the tire and the back side of the tire are all free of oil, so that it indicates to anybody inspecting it that it's not a leaking wheel seal, because they'll definitely pull you over for that. We may want to put the wheel back down to final torque these, which I'm going to do because it's up in the air. So we'll come back to this, but don't forget to torque those on. If you've had the wheel off here at the wheel studs, very critical that you torque those wheel nuts with a torque wrench in a crisscross pattern. So get them on snug, bring them up to your first torque, usually about halfway of the final torque, and then go to your final torque in a crisscross pattern. Make sure that these hand holes for the valve stems are opposite one another, because if you don't get them lined up right, these two dual wheels, the driver may not be able to access the valve stem if you haven't paid attention to orientation. Or you get them both on the same side, and then you have a dickens of a time filling it with air. And whatever you do when you're filling these vehicles on a service, you make sure you fill the inside tire as well as the outside tire, okay? Because very critical that you have equal tire pressure in both these wheels. We're going to go ahead and we're going to adjust up the brakes, so we'll zoom over there and have a look, and then we'll drop the wheel down and we'll final torque it, and that's it. What we're going to do now is we're going to adjust up our brakes. So what we're going to do is we're going to rotate our adjuster so that the S-cam tightens up here, and we can actually watch the S-cam orientation as we do it. It should be turning in the direction that the push rod would turn it, so it's going to turn this way. As we watch it adjust up here, you can likely see it turning here a little bit. And what we're going to do is we're going to wind that in until the brake shoes are right against the drum, and we can verify that just by tapping on the drum, or in this case the wheel's up so the wheel won't turn. And then what we're going to do is we're going to, on this Arvin Meritor style, you have to use a little screwdriver or a little something to hold that tang out. See that little pawl? That little pawl has to come in disengaged in order to back the brakes off. And what I'm going to do is I'm going to go 1/4 turn to start with, and we want to make sure that when we back them off, that there's a 1/4 turn, that the drums aren't being touched by the linings or the wheel's not dragging. So in that case, that's good. If it was on the ground and you couldn't spin it, you could just take your wrench and tap on the drum. You can hear that hollow sound. That means the shoes are up out of the way. If you hear a dull thud, either the shoes are in the way or you got a cracked drum. In this case, we already had it apart, so we know it's not a cracked drum. So once those are set up, then what we'll do is we'll get underneath here and we'll measure with our tape measure, and we'll check the brake stroke from side to side. All we have to do there is just reach in, take a measurement here, like so, Okay, now grab our, I like to use a 1-inch wrench and pull on it. And we've got about 3/8 of an inch hand pull method, which is acceptable. 3/8 to 5/8 of an inch is acceptable for hand pull method. Okay, so what we're going to do now is we're just going to lift the vehicle up off the jack stand, and we're going to pull our jack stand out. And now we can drop our wheel, and now we'll just undo this piece here, this valve, and we'll slowly drop that down. And it doesn't hurt as a final check if it's had a wheel seal leaking and stuff, just to pop this plug here out. This plug right here, we'll just pop that plug out, and we'll check that it's even with the fill hole. Make sure your air ride's at the right height before you do that, because that needs to be at ride height to give you the right level. And just make sure that everything's cleaned off.